Today we're going to talk about some indefinite integration. This is one of the older A-level papers in Hong Kong, and I'll explain how to do it. So in part A, this one's really straightforward. Whenever you see in this part right here, there's a 1 plus x squared, you know we will have to use this identity. I'll write that here. And this identity is too basic, so I'm not going to explain it here. So we have, obviously there's a dx here. We'll use a trigo substitution, which is x equals tangent theta. So d of x equals this thing right here. That's just tangent cubed theta. And obviously we have secant squared theta d theta. That one's really easy. I'm not going to explain that. This one cancels out. So we have tangent cube theta, which means we're going to have secant squared theta minus 1 times tangent theta d theta. And we'll have this expression. This is all just really straightforward. Here we have x, and we have d of x. So we get x dx minus sine over cosine, and then we could do another substitution here. So let's say u is just 1 over cosine, which is just not 1 over cosine. Let's say u is cosine. So du is negative sine, which means we have x dx plus 1 over u du. And this is really straightforward, which is just x squared over 2 plus natural log of cosine theta. Cosine theta, theta is arctangent x, so this is cosine arctangent of x plus c. So this is part A. And part B wants us to integrate, what is that? X squared arctangent of x dx. So we could do a little bit of biparts here, and because if you do biparts, if we have this thing inside of d whatever, if we differentiate arctangent of x, let's say there's this is just a note. So let's say we have z equals arctangent x. dz of dx is 1 over 1 plus x squared. This is really straightforward. I could do some explanation right here. So x is tangent z. dx dz is just secant squared z, which is 1 plus tangent squared z. And dz of dx is 1 over 1 plus x squared. So we could use this fact when we're doing our biparts, and I'll just throw this away. This is just intuition, really. I'm just trying to explain why we're going to do biparts. So this is 1 over 3 arctangent of x dx cubed, because x cubed differentiated is 3x squared, which is why I have the constant there. This is too straightforward, I don't really have to explain that. And this is the biparts. X minus 1 over 3 x cubed d arctangent of x. And the arctangent of x is just 1 over 1 plus x squared. And I believe by now you know how to do this, because this part right here, oops, not including the constant, this part right here is just part A. So by part A we could derive this is 1 over x cubed arctangent of x. That's some terrible handwriting, my gosh. Minus x squared over 6 minus natural log cosine, and that thing has to be multiplied by 1 over 3. So 1 over 3 natural log cosine arctangent of x plus c. And there we have it. That's the end.